Hi, I'm Andy. Welcome back to C# Puzzles. You've probably encountered some error messages in your code so far. You've maybe written code that's broken and you've been presented with an exception. That's what we call an error, an exception. And the program stopped running. So C# has exception handling. It's basically a try-catch block. So you wrap your code in a try statement, and then beneath it you have a catch statement and a block of code. And if you encounter an error or an exception within your code, within the try statement, the catch statements run. So this is a really good way of sort of fixing any errors that occur, or maybe you just want to rerun that code again. Just ignore the error, rerun the code, get the correct input. So you're trying to fix the error, or you're trying to handle it better. A lot of people will use this for logging. So if an error occurs, you want to log the error and you want to send it to database or send it to file server. Let me give you an example. So let's say your program's looking for a file on their computer, but the file might not be there, right? So if you've written a line of code saying, okay, go to the user's documents folder and get this file, the file's not there, the program's going to crash, right? But that's kind of bad. So we would have that code within a try statement, and then within the catch, if we can't find the file, because it will throw a file not found error, that's a standard error. The C# language has a list of standard errors. So if you can't find the file, it'll be a file not found error. So if the file not found error occurs, we catch it in the catch block, and then we do this. We maybe say, oh, sorry, I can't find that file. Could you check that it's there again? And then we rerun it. So this is very common error handling. It's really useful when your code gets up to some monkey business. As you'll have noticed, this happens a lot. Hardly anyone writes code perfect the first time. There's always errors, there's always exceptions, logic exceptions. So this is a way of catching them and letting the program fix itself and continue auto log the error, okay? So the program just doesn't break. Let's take a look at try catch. It's going to be very useful going forward. Head on over to GitHub, the link's in the description for Puzzle 7. We can download the code by copying the HTTPS URL. I think I'll use the command line this time, so I've just changed directory into wherever folder I want to save it in, and I already have Git installed, so I can do git clone, paste that in there, and I'll just download it. If you need to get Git, I believe I've told you this before, just type in git download, and there you go. Go to this website, download it, install it. I've covered this before. So okay, now you can see we have the code here. Let's take a look at the program, and I'll run you through the examples. Now this is going to be slightly different than what we've done before. The structure's different. If I go down the very bottom, I don't have example A, puzzle A, example B, puzzle B, example C, puzzle C. I have 2 examples and I have 3 puzzles. This is because I want to start showing you how to handle errors and how to debug the program. Really, from now on, things are going to get a bit more complicated, and if you don't know how to use the debug tool in Visual Studio, it's just going to be difficult. I'm guessing a lot of you have sort of tried to do this so far, but you could have got away with not knowing debugging at all so far. So I'm just going to give you an introduction to it. So basically I'm going to be showing you why we've got these try-catch things and how to use the actual debug tool. So I'm just going to run example A first. I'll just show you some errors. So I'll just comment out example B. Let's just do example A. So in this code, we have a whole bunch of sort of magic numbers at the top, hard-coded values that we'll be using. Now, you can't divide anything by 0. You know this from high school mathematics. So when we try to do a division by 0, we're going to get an error, okay? If I was to type in just 10 divided by 0 there, the compiler's going to tell me there's an error and it's not going to let me run the program. Okay, that's why you've got that red wavy line. This is a compile time error. So it knows there's going to be an error before we compile the program. it's not going to let me run the program. A way around this, because I want to demonstrate an error to you, is just to put the error in a variable. So we'll set input to 0, and then we'll divide 10 by input. So we're still dividing 10 by 0. It's just not going to catch this in the compiler. It's going to catch this when I run the program, and that's called a runtime error. So I want you to understand that there's different terminology depending on when the error happens. Does it happen before we compile the program, or does it happen after we've compiled and run the program? So let me just run this and I'll show you what an error looks like. Just thinking about it, it's running. Here we go. And it's printed out the top of it, so it's printed out this section, fine. It's got to this line here and it's went, no, 10 divided by 0, error. Divide by 0, exception. Attempted to divide by 0. So the compiler's showing us this and it stopped the program. It's given us a little arrow here, a big X, and you can sort of hover over any variables and see what they are. So input 0 and answer 0 because it's not done this yet, it's not done this calculation. If I hover over is active, it's true, eyes. You can see you can hover over things, and this can help you troubleshoot, but it's stopped. So we never ever want our programs to have an exception, because the program just breaks, it stops running, the user would notice. So we don't want this. We want to test our programs to avoid this. So I'll just, you can click continue and it'll just stop running, right? The IDE there just kind of paused it before it broke to show us what happened. Now, an old school version of testing is just using console write-line. So we've been doing console write-line a lot, and I've told you that once you get a bit more advanced and you start using frameworks and things, you're still going to be using console write-line even although you're not working with the console itself. And we'll use it for testing. So you can kind of see here right at the start, I've written testing, my name and a date. It's very common because you're going to be writing a lot of these console write lines as you test your program line by line, section by section. And you want to remove them all from when you sort of finish your code and commit it and send it to the rest of your team. You don't want the code to be filled up with testing comments. So what I always do is I always do testing in capital letters. That way I could always do, if I do Control and F, I could go testing, and you can see how you can find all the testing comments. So you can find everything you've written if there have been thousands of lines of code. You've got the date you've written it. That will tell anyone that finds it later on, hey, you know, the year's 2029 and this is from 2024. Maybe we should get rid of this. Anyway, all I'm doing in this console write line is I'm saying it's a test. This variable apples is of type, and I'm just using get type to display whether it's an int or a double or whatever. This has more to do with this stuff here. You generally put the testing before and after whatever code you want to do. Anyway, before I demonstrate this, I want to show you how to use the debugger for this. But you should be capable of writing testing comments by now. To use the debugger in Visual Studio, you go to this sort of square section here, this grey section, and you just click on it and it puts a little red dot. And this is a breakpoint. Now when we click run, play, whatever, it'll go through each line, and then whenever this code gets called, so when is active is true, remember this is the same as writing true. Okay, that's the same. If I just leave it like that, it's the same. The program will stop here and it'll allow me to kind of hover over everything. So if I do that, in fact, let's do it here. Let's do it right in the if statement. So I can just click this again to remove it, click it again, hit play. And you see how it's highlighted. It stopped my console window, and it's here. I can hover over it as active true. Now you can see up here you've got these little buttons. Step into is more like if this was a function. We could then go to that sort of subroutine that takes you to the code of the function. I'll show you this later on in the course. the most common thing we're going to be using is this one. So you can click this, or you can hit F10. Okay, so I click this, takes me to the next line, the bracket. If I hit F10 on my keyboard, it takes me to the next line. It's the same. So you use this to pause the program. You get your debugging statement, you click on it, pauses it here, and then you can use this to step through the code line by line and just see how it's behaving. So I can see here, input 0, that's going to give me a 10 divided by 0, that's going to give me an error. If I click this again, or hit F10, doesn't matter. Next thing happens is we get the error. Oh, that's what's causing the error. So I'm giving you a very simple example here of how to do this. If I just click continue and get us out of that. So in the next section, there's another kind of error here. If I uncomment these two. Now the reason I commented these out is they wouldn't run, otherwise you have a compile time error. So here we have apples. So I have apples as 10 here, divided by I is 2, so 10 divided by 2. If I hover over it, you think, oh, the math's okay, 10 divided by 2, but it's telling me here one type's a double and another type's an integer. So apples is an integer, I's a double. In C# are very type specific. The memory space each of these variables is saved in is configured differently if it's a double or an integer or a string or whatever. So you can't easily just save one as the other. They have to be the same type, and this is what it's telling me. I've also got show potential fixes here. So you can click that and it can tell you, hey, if we cast this, it's giving you suggestions, and there can be multiple suggestions. That would work though if we use casting and just make that an integer. Yep, because although it's able to know that we want this to come out to be an integer, so it's just going to do it in the background and make them both integers. You could use that convert to int32 would be another one. That's the same, yeah. So apples is already an integer, so we could actually, rather than do them both, you could, if you wanted to, just, it's I that's the trouble, right? I's the double, and we want it to be saved as an integer. So as long as they're both integers, you could do it that way. You could do it that way. Okay, so you've got multiple ways of doing this. Some might be faster than others, some might be more readable than others, but you're going to have 2 or 3 ways of skinning a cat here. So I'll just leave it like that. And then this should work now if I run it. Oh, sorry. that's still gonna give me an error. I'll stop. If I make input, well, you could do it, make input 1, and that would be fine. Program runs, okay. And you can see here my comments, my test comments. It's going apples is of type system int32, I is of type system double. So you could move this around, maybe move it after, before. So this is like old school testing before we had an IDE and we had debug points. You could put debug down here, you could stop it, run it again, and it stops us down here, and you could hover over apples as 10, I is... So you understand how you can use this debugger. Oh, I don't mean to run that again. How you can use this debug tool to pause the program, step through it line by pressing step over, the step over button. If I run that again, I really want to just hammer this home. You can go step over to go to the next line, and again, or if you hover over it, it tells you press F10, right? Press F10. That's just really what I wanted to hammer home to use. So that's example A. Now for example B, I'm going to demonstrate to you how we would handle errors in a real program, because this is great, this does its thing. But if there's an error, especially if it's user input, if we allow the user to enter something, they may enter something that we've not ever thought of. So we need a way to handle the user error. That is, maybe we want to change it to a standard output, or we just want to display something or whatever. So the easiest thing to do is you've got your code here, right? This is kind of the code we've been writing so far. We've got input, we've got a while loop, we've got a counter, we're going through the while loop. We're going to get this zero division error again here, okay? I've also said, look, for loop 3, just throw an exception. This throw new exception stuff here is just me telling it to throw an exception. Why would you want to do that? I'll show in later courses, there's multiple ways of forcing code to do stuff. Forcing one function to do something based on the result of another function. This is just another way of doing it. Okay, but how we trigger exceptions, that's just how you manually trigger it. It'll become clear in later videos why you would want to use this. But this is the kind of code we've been writing so far. The easiest way to handle errors is to use a try catch block. Okay, so we try the code in here, and if there's an exception, we use the catch blocks and we do the code in there. Now the catch blocks, a lot of the things you're going to see on YouTube and online are just going to have this. A general catch, any error that happens in here, display this, and we've just got, you know, the error, and that's like the variable for the error. And in C#, you really are just interested in the message. So we'll cover objects soon, but this is an object, and we're interested in displaying the message. So this will catch everything. Generally, we don't want to do this. We want to make it specific, although quite frankly, you do need this. But the advice you'll be given is make it specific. So if a specific error happens, you can define a specific response. But generally, you're going to want a catch-all, right? Otherwise, if an error other than divide by 0 error happens here, this will break, but this will otherwise catch it. So you'll notice the name of the error as well is the same as the name of the error displayed in the IDE. So if I 0, if input 0, 10, this is going to give us a 0 division error, right? Let's hit the debug point, hit run. Oh, sorry, I'm running example A there. Let's comment that out. Let's get to example B. Let's run it now. Okay, so the debugger's stopped in our little red debugging point. Now if I hit F10, or again, step over, go to the next line. Next line, input, we're going to get a 0 division error here, okay? Next one. And you see how divide by 0 exception here is. That's kind of how you can find out what to put in the catch block. That's the name of the error, right? So if I stop that, but did you see how the next line it was caught here? If I do that again, so step over, we're going to get the error now. Boom, it skips all this and it goes to this specific catch block for that error. And then if I hit F10 again, or step over, it's going to print this line. And if I hit continue, sorry, you can't divide by 0. And it's giving us the error, and the message is attempted to divide by 0. So the message is really, it's the human readable part. If I get rid of that and just do EX, which is the variable we've assigned to this, get rid of the debug because we know it's just going to run now, and I hit run. See the complicated output we get now? Error, and then we get all this, which is, you see the messages there, but we don't really need to read all this just now. So that's why I have the dot message. Now if I get rid of this, it's just the general catch. this will be displayed this time. Run it. General error, attempt to divide by 0. So this is your catch-all. Always have these, although you will hear most senior coders saying everything should be specific, but you're never going to be able to get them all. So always have a generalized one. That's my opinion. That's my opinion. Some people would disagree with me. Okay. So let's say I make this 1. That's not going to be a 0 division error anymore, okay? But in loop 3, I'm going to just create an error. Instead of me creating some hard to read logic, I'm just going to say, hey, let's create an error. And I just want to show you how you can sort of step through here. So if I just put the debug point at the if statement, we'll run this. Okay, so it's displaying this line. So we're in loop 1. If I hover over I 0, you can hover over previous ones, I 0, I does not equal 3. So if I do step over or press F10, it skips the whole thing and goes to the increment I. And now it runs it again. So we're doing the while loop again, but this time I is 1 because this has been the incrementation. Go through it again, prints it again. See, you get the second line of code there. Does I equal 3? No, I is still equal 1 at this point. F10. Oh, sorry, if I click on this, F10, see it goes to I. Next bracket, I now equals 2. F10, 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 prints it out again. The third line. What does I equal now? If it's going to let me hover over it, I equals 2. So keep on clicking step over, and you see you get stuck in this little loop. And I equals 3 now, I should think. Yeah, if I hover over it, I equals 3. So this time it's going to go in here. And you see now we're in there. Now we're inside this if statement. Throw new exception, test exception. Boom. Caught by the catch block. Okay, this is very basic debugging, very basic try catch. If I stop running the program now, I wanted to give you those examples to give you that knowledge, because I'm going to be really mean to you now. I've given you 3 puzzles, and as you can see, there's lots of code here, and as you can probably guess, comment example B, go to puzzle A. I'm going to get you to fix these up. Broken, rubbish code I've written here. So get past Gandalf. I want you to add a try-catch block to this code. So wrap it in a try-catch block and then debug it using the debugger. Okay, now you're kind of getting some wavy lines here. It's going, oh, what's happening here? The problem is going to be here. Okay? The problem is going to be here. And when you run through it, if I hit run now, so as you can see, the if statement, if we click no, this is just a console write line, that's going to work. But if I hit Y and hit enter, boom, you get this kind of error. So I want you to do a try-catch block, and I want you to make, as well as a general one, a specific one, and then I want you to fix it if you can. All right. You don't really need to fix these. There's so many ways to fix them. You might not fix it the same way as I do, but the aim here is, I'll stop running that. The aim here is to learn how to use the debugger and do try-catches. If you can fix it, great. This is also generally what a programming job is like, except it's just more complicated spaghetti code. You have to go and fix something or add a new feature. So puzzle B, yeah. Oh. So again, try-catch block to it. I'm not even going to tell you where this is going to break. There's not that many lines of code. I'm sure from our whole example up here with your sort of doubles and ints and whatnot, you should be able to spot this. So I'm not even going to give you any hints for that one. Puzzle C, a bit trickier. Puzzle C, a bit trickier. Make that active. So Bill Gates has got tons of, I can't even pronounce that in English, how much money that is. We're using decimal, which is more accurate for money, and we've got an M there because it's a decimal. So we're wanting to add 1 to Bill's bank balance, and you're not going to believe this, but see that, well, you should, see that amount of money, that's actually the highest a decimal value can be in C#. So when you add 1 to it, you're going to get an error. Okay, if I run that. But overflow exception, it's overflowed the maximum value. So that's the maximum there is. I'm not setting you up for success here. That's the maximum decimal can be. Add 1 to it, you get a system overflow exception. Do a try catch around it, but you have to solve this logically, because everything else you could just have solved making little code changes. So what you're going to need to do is you're going to need to find a type that can hold more than this. Hey, it's not going to be as accurate as decimal, but is there a type other than decimal that can hold a bigger number? Okay, you could also have sort of found, this value by doing decimal.max value. Why am I telling you this? Well, that'd be really useful to use in like some kind of if sort of statement, right? If something, if it's equal to max value, if it's greater or less than, you know, you could use that in some kind of if statement, right? Rather than type that out. Another way to do this is just to have 2 bank accounts. So we have one bank account that's absolutely full, and if this bank account's absolutely full, then add it to the second bank account. So you just create like a second bank account. Play with it. Play with it. That's what I would suggest doing, but that's more you have to fix it logically. You can change the logic of it, or you could change the type, or maybe there's other ways. That's just the 2 that came to mind there. Use the debugger, step through these programs, add try-catch blocks, try to solve them if you can. As always, the solution is available in the solution branch of the GitHub repository. If you click there, the solution is in this program CS file. Okay, there's all the answers. Now let me show you how I would troubleshoot and solve these puzzles. So right at the bottom, I'm just going to comment out example A and example B. Don't need to run them. Let's do puzzle A first. Okay, get past Gandalf. Add a try-catch block to this code and debug it. Okay, so first thing first, let's just run it and see what happens. I know I've done this in the examples, but I'm just going to show you how I would do this. So we know that the answer is going to be yes. Get rid of my firewall there. So system null reference exception. It stopped us and it's pulled us out of the program, and it showed us this code. So we know right away we're getting a null reference exception. Okay, stop it. And it stopped it at this line. So generally what I do is, it's fairly obvious what the issue here is, but sometimes it might not be. So what I usually do is put the breakpoint a line or 2 before it. Because this is an if statement, I'm going to put the breakpoint on the if statement, because it might, although it's not in this example, it might be because the if statement's got the wrong logic. I mean, you've seen how easy it is if you have like or statements or and statements to get them confused. So it's good to troubleshoot like the line before. Okay, so let's run it there. Hit yes to move us to the breakpoint. Breakpoint's highlighted. I can see that, what is input? Yes, so it is yes, I can see that is correct. That's what I want it to be. Okay, right. Hit F10 or hit the step over button to go to the next line. Oh, sorry, it's taken us to the bracket, which is technically the next line. Okay, the line after that, we're on this, and it's still running, so I know we've got into the if statement correctly. Let's run that. Let's hit F10 again, step over, and boom, we get this system null reference exception. Now this null reference exception here, I'm going to copy this because that's the error we want to catch. That's a specific error we want to catch. Okay, but challenge was null, so it's kind of telling us this is the problem here. Fairly straightforward. So the easiest thing to do, there's two ways you could do this. You could put like a null catch somewhere, perhaps inside the if. I wouldn't do it inside the if though. I would usually do it after getting the input. So if input does not equal null, and then, you know, put the if statement in here. Yeah, and then else, you know, do whatever. Maybe re-ask or something. So only if it doesn't equal null do we run the if statement. This is a very common piece of code. So if you've done this, very well done. But you don't have to do anything like that for this, because I would argue that this probably shouldn't be null. We could probably refactor this to include this statement, right? In this example, we have to make sure it's the right quotes. And then we could just put maybe challenge in here. What? And get a $sign for string interpolation. So that's going to fix it without putting any other code in there. If I get rid of that and I run it. So if I do the yes, boom. Okay, it runs this time. So there's multiple ways of fixing these. There's other stuff you could have done as well, but those are the two things that would immediately jump to mind for me. So that's how to fix it, but we still have to cover it in a try-catch block because there might be more stuff here, more errors, or potentially more errors that we've not thought about. So that first catch one, we'll make that null. Say it's highlighted, it's available here, null reference exception. We know that from the debugger. And we could maybe have, I don't know, console write line, just a null error. And then you could have the message. So we're going to cover objects soon, which this is that when you see a variable and a dot, it's an object. We're just only interested in that. I described this in the intro sort of video to this puzzle. We're only interested in the message, the human readable part. So that would be okay. We could also have just a general catch. Have I got a general catch above? Yeah, that'll do. Sort of catch everything. Yeah. So I would say that would be good. That would be good. Also, if you did the if you did the null, whatever, right? It gets rid of the green arrows there. Just remember though that with input, if you hit enter right away, it's going to give you this blank input, right? So a lot of people would do this or that. Or I believe there's also things like string.empty. So you see various ways of writing this. I use this a lot. So it's up to yourself. Multiple ways of doing it. Alright, that's the answer to puzzle A. Again, the main aim was for you to learn how to use the debugger. Let's get puzzle B sorted down the bottom. Let's make it active. Comment out puzzle A. Let's just try running it. Let's try running it, see what happens. Enter a number with a floating point, 1.2. If I click it and do it properly, 1.2. System format exception. Not in the correct format. So it stopped me right here. I can see the sort of fancy stuff that's happening in this line is this conversion. That's the thing that jumps out immediately. So input is of double type. And we're trying to convert the string input of this to integer. So an integer can't be a double. So I think you probably want to change this to double. I'm going to show you something else here. If I stop and I run it again, let's say I didn't enter 1.2. Let's just say I entered 5, which is a whole number. That's probably easier to convert to an integer, right? Because it's not a float, it's just a number. It's went past that line, you see. Because convert to int 32 can convert 5 to an integer. Can't convert 1.2 to an integer because it is a floating point. So it's went past, and then we've hit another error. So you notice how the error's different. Index 0 based must be greater or equal than 0. And the error here is that should be 0, not 1. Okay? Because computers start counting from 0. So what string format does is it looks for the variable after the comma, and that's variable 0. So that should be 0. And then the next one would be 1. Stop running this. So that should be 0. If I had another one, it should be like this. Oh, sorry. Maybe we have something like this. I'm just going to give us another variable. So num3, oh sorry, num2. So num2 would be variable 1, and input would be variable 0. Okay, that's just an example. So if I run it this time, and I type in 5, which is going to be able to be converted to an integer. I get 5 and 3 and it runs. Get rid of that. So that's one fix. I'll just leave that in just now. Put that back. I'll put that back to 1 in fact. But if we enter a floating point number or a double like 1.2, it breaks here. So that's really where I would put the first breakpoint. Run it. It stops immediately. Doesn't like it. Well, it stops immediately because it's the first thing that's requested, right? It's displayed the text, and then the next things are input. So if I type in an input 1.4, sorry, I'll have to just step over so we can get the input. Yeah, sorry, I typed it in twice. Hit enter. System format exception. It's not in the correct format. So I would fix that by going to double. And you can, while in debug mode, enter stuff. But you probably shouldn't because you've edited the code while the program's still running. So you shouldn't assume that these changes are going to be reflected in the current program. You should always stop it and then edit it. Okay, let's get rid of that. And you see the red lines disappeared now because we've stopped the program. So if you're running the program and you edit it, the program's already moved all this into memory, it's been compiled. So the fact that you're changing text here doesn't necessarily mean that the program's going to reflect that change. So let's do double. This last one, sorry, I'll get rid of this junk code there that we're not using anymore. I'll put the breakpoint there. Run it. do a whole number this time, 4. Well, in fact, I could, because we've fixed it, I could do 4.5, right? And it should get past it. Yep, I get past it. And it stopped us here. But if I continue, we get an error. System format exception, and it's to do with this. So if I do 0 there, this should all work now. Numbers, there we go. Bingo, works. So that's how to fix it. We still have to cover it in a try-catch block. And it was a format exception. This is the specific error. So just format error, I guess. And then we'll just copy the general exception. Yeah, that's good enough, right? That'll do everything. You can always test it by like doing the error again. So if I type in, if it was 1, then we would have caught that format error. Put that back to 0. And if we did that int 32, we ran it, and I did 1.5 format error. See? Let's get that back. So that's the solution to puzzle B. Let's comment out puzzle B, don't need that anymore. Puzzle C. Right, Microsoft money. I've already told you that this is the largest a decimal can be in C#. I could have also got this with decimal max value. So for example, I could have went and if I just comment out the rest of this code, I'm not going to run it. And I just do a console write line. Just do a concatenation, just do a plus, doesn't matter. Yep, Bill Gates bank balance. So this is a sort of troubleshooting as well, using the console write line to find out what this is. So if we run this, see how I got that number? It's the same number. Stop and I just undo what I did. Control Z, Control Z, Control Z, Control Z, keep doing it, we'll get back to normal. There we go. I just had to put an M in the end because it's a decimal. If I run the program as normal, what's the error we get? Right away, system overflow. Did it happen right away? What value was I? We don't know. You could put the breakpoint here and step through, or you can put 2 breakpoints. It will just hit this one and that one. So let's run that. So first off, I is 0, we're stopped in this breakpoint. Continue. We just hit continue and it's just going to go to the next breakpoint, or we can step over. Continue is useful if the next breakpoint's like multiple lines away. But all our next breakpoints, that you could just step over, or you could just hit continue, hit the next one. So what is the bank balance? So we can see it is there. If I try to do one more, if I hit continue now, it'll try to go to this breakpoint. Now we all know it's going to break in this line because we've ran the program already. But if I was to continue, I would only know that it broke between this breakpoint and the next loop. So I really want to do step over. I want to see if it breaks in this line or if it continues to the next line. Okay, so see it's continued. I increment. What is I now? I is 1. What is the bank balance? Oh, so it's able to take one more. It's done another one. Okay, that's good. It's done a few. It's done a few. And it stopped. And it stopped when I was 3. So you can see I've reduced the very last digit of this by a few, so it would go through a few loops for you and then it would fail. Okay, so there just comes a point where this is going to max out. That's the error. How could we fix this? There's 2 ways of fixing this. I'd rather them at breakpoints. Probably the easiest way to fix this in C# is to use a different type. Big integer can store more values than a decimal can. It's not as accurate. Remember, we're using decimal because we need the accuracy with money, and we have to get a big integer, we have to do this parse. Well, delete. So if we've done this, this will just run now. See, it runs now. It gets past the 5. I always get stuck in this loop before. So that would run. Decimal is more accurate than big integer. This is a very silly example. You wouldn't program it like this if it was anything to do with money. But just as a logical thing, I'm thinking, hey, that big integer contains more than decimal. Can I do a max value for that? I don't know. This might not work. No, it doesn't like it. So max values sort of like a function of decimal. We can't just do it for big integer. It's worth trying though, right? So that's one way of doing it. Let's just surround this with try catch for the moment, and then I'll show you the other way with using 2 separate accounts, which is just more of a sort of logical way. So it was an overflow exception, so it was a catch, overflow exception, EX is the variable that we're going to use, console write line, if you hit dot there, it can tell you all the things you can use, so I'm just going to use message. Alright, and we also want copy and paste the general catch-all in case something else happens. This is also useful if someone else comes in and edits your code, and you've made a very specific catch here. So they've come in, they've edited your code and they've been sloppy, and they don't know there's an error, and they've not added in a specific error themselves. That's okay, this will catch it. It was already in place. Right, so big integer. That's the first sort of way of fixing this. If I put that back to decimal, another way of fixing this is just having a second bank account, right? Bill Gates needs a second bank account to take even more money. I could just instantiate this, just copy that, call it number 2 maybe. Set it to 0. And then I can sort of throw in an if statement in here somewhere to sort of check using decimal max value if it's greater than the maximum value a decimal can hold, then use the second bank account. Right away, let's do it right away. Yeah, because we can't really do the rest of this code. We can't do this without it breaking. So we have to, have to do the if statement first. So the sum we actually want to do is this, right? Well, just put it in there. Then we want to do, so if it's greater than, less than, doesn't matter. If it's less than the max value, I want to do this. Yeah, it's just the way you think. I want to do account 1 and account 2. So if it's less than max value, use account 1. Otherwise, we'll get an else in there. We'll just use the second one, right? I'll just put some 2's there. What? So use the so if it's less than the maximum value decimal can be, use the first account. Otherwise, just use the second account. Means we have to then edit this statement, right? Because we need a second one to show us our second bank statement. Bank balance 2 is now that, right? If I get rid of these blank lines, tidy it up a bit. That should run. So balance 1 is only getting incremented to this loop. And then we're starting to see it in the second account now. So that'll be, I don't think Bill Gates has ever seen his account at $3. For Bill, if he sees the number 3, he assumes that's at least million. I think I read once that, like, if you were to see change lying in the ground, there's a certain value where you wouldn't even bother to pick it up, right? A working class person like me and you, if we seen like a penny in the ground, it's probably not worth our time to even bend down and pick up. In Australia, if I seen like a 5 cent or a 10 cent coin, probably wouldn't bother. So what number would I bother at? I'd probably start bothering 50 cents. I'd bother to bend over and pick it up. For Bill Gates, his equivalent of 50 cents is something stupid like $70,000. So if Bill Gates is walking around and he sees less than $70,000 lying in the ground, it's not worth his time picking it up. It was something like that. Don't quote me in the 70,000, but it's tens of thousands of dollars. It's just like pocket change to him. So yeah, for 3 he wouldn't even bother. But it does work. I just wonder, we could probably just do plus plus there, right? Yeah. So you could do plus plus, or you could do plus plus there as well. If you want to do the shorthand, that would work if I run it. Yeah. All right, guys, that's the puzzle solved. I hope you learned how to use the debugger. That was the main issue here, not solving these. Although I might do more of these in the future because it's kind of like a little coding job, sort of simulation going on there where you've found a bug in the code, or maybe a user's reported a bug in the code, and you have to sort of go through there and sort it out. And the try catch, we're just going to be using these from now on forever. So the days of you not using try catches are over. Welcome to the real world. Another puzzle down. We're starting to get a bit more advanced now with the try catch looking at errors. The same puzzles available in my Python channel, and you might want to check out the premium puzzles on my websites if you want to support the channel. Now try catch in Python they do try except, it's the same thing. So we are essentially trying to strengthen the program against known errors, sometimes unknown errors as you've seen. So for example, you might use this, I'm trying to think of a really basic beginner example, But so I've not covered dictionaries or lists yet, but just imagine, you know what a list is. It starts at 1 or 0. 1's this, 2's this, 3's this, 4's this. Say you've got a list of 5 items. And we use a while loop because we've just covered while loops. Go through the list. What happens when the computer gets to item 6? Item 6 not in the list. Item 5 is the last one, so it'll throw an error perhaps. Well, that's a known error. So that piece of code you might want to cover in a try-catch and then put a specific error in there in case something goes wrong with the list. Or, when you're writing the program, you're expecting a list with 5 items. But in 5 years' time, they bring in a new developer and they change the list somewhere else in the program to 3 items. And then all of a sudden, that piece of code breaks where it wouldn't have broken before. So your try-catch will do different behavior there. So you can essentially do recovery behavior. You can use a try-catch. If there's an error, do recovery behavior for that specific error. And it's just good practice to do everything in sort of try-catches. Even though technically, I suppose the technical answer is you want to use a try-catch whenever you expect the program to break, but you also want to use it for general recovery. You don't want the user to ever be presented with an error message. Okay, let's continue on the next puzzle.